presently trying to raise $100,000 to write my next book of poetry. Poets in Canada and North America don't tend to range very far outside the catechism of their training. I think that one of the difficulties of being a poet is that no matter what kind of poetry you write, whether it be very conventional or whether it be very experimental, ultimately you're still writing words and putting them on a page. And these poems often look the same. It's a kind of problem that faces writers who are working in the fields of the arts, painting. It's very difficult. It's very difficult to be an innovative painter because no matter what kind of innovations you might bring to bear upon painterly technique, you're still putting colors on colored mud on a canvas. So I'm proposing to various funding institutions this project, which I've tentatively called the Xenotext experiment. This experiment is a literary exercise that's trying to explore the artistic potential of genetics in the modern milieu. Hoping to make literal a renowned aphorism by the American writer William S. Burroughs, who declared in the 1960s that the word is now a virus. And I think that he was alluding to the way in which culture seems to be a kind of disease that takes over our minds and gets passed along like a form of communication, very much like a biological entity. In this experiment, I'm proposing will address some of the sociological implications of biotechnology. I'm hoping to manufacture what I've called a xenotext. It'll be a very beautiful, anomalous poem, something whose alien words, though, might actually subsist like a parasite inside an organism. I would like to be able to write a poem that could become quite literally a living thing. Now, a scientist at the Pacific Northwestern National Laboratory named Pak Wong has published a scientific article a couple of years ago in which he demonstrated that it was possible to store data as sequences of textual information inside genetic nucleotides. He could actually encode information in genes, making messages, if you like, out of DNA. And we can implant these messages apparently into organisms, bacteria, for example. And these messages can actually persist, undamaged and unaltered in an organism, where they can be preserved for later recovery and decoding. And Wong enciphered the lyrics to the song "It's a Small World After All," took 2 or 3 lines from that, and enciphered them as a sequence of DNA, which he inserted in the bacterium Deinococcus radiovirulens. It's a bacterium very resistant in hospitable environments. In fact, this bacterium is a very tough little bug. It can survive 10 times the dosage of radiation that would kill a human being instantly. That's the kind of bacterium that could survive an atomic attack. And Pak Wong came up with this idea because he wanted to protect information from potential disasters, catastrophes that might befall our planet. And he said that organisms on Earth, many of which have survived for hundreds of millions of years, provide an excellent candidate for protecting this information for future generations. So that if, for example, the Earth were hit by an asteroid, or if we actually had a global nuclear conflict, we might be able to reconstitute our culture by storing it in bacteria and then decoding it later. Likewise, an American artist named Eduardo Katz has used a genetic process of encipherment for his own creative purposes. He took the biblical sentence, "Let man have dominion over the fish of the sea, and over the fowl of the air, and over every living thing that moves upon the earth." And he encoded that phrase as a strand of DNA, which he implanted into a microbe. But he subjected that microbe to doses of radiation so that it would mutate. And of course, the message would change as a side effect of this mutation. He wanted to demonstrate that it would be possible to use genetics as a kind of literary medium, and that it would be possible through manipulation of the actual organism itself to change the message so that we could actually cause it to evolve or mutate. And finally, an Australian scholar named Paul Davies, an astronomer, who's a very respected professor searching for extraterrestrial intelligence, noted that because we can actually store information in DNA, we can actually theoretically do this. It might be conceivable that an advanced civilization might use that as a medium of communication, rather than sending a very complex and large spacecraft across the interstellar void, or rather than maintaining some sort of radio beacon over many thousands and millions of years, all of which are very expensive and inefficient ways of communicating across interstellar distances. We might actually, instead, encode messages into viruses or organisms and then actually send them out as little envoys, very cheap envoys that they can maintain themselves, they correct their errors in copies, they can face unknown hazards and survive them, and it might be conceivable that alien messages already exist, perhaps in the DNA of bacteria or organisms on our own planet, that these messages may have already been sent here by aliens. Now, all of these thinkers have really suggested the degree to which biochemistry provides a potential substrate for writing. That the genetic code is not simply a code that governs the development of an organism and the maintenance of its function, but that it can become a kind of mode of transmission, a vector for artistic innovation and cultural expression.